everybody, welcome back to Algebra 3. Today we're starting a new topic. It's a new year, we're going to do a new topic. It's topic 4.1, higher degree radical equations. It looks like we have two goals, but we actually have three goals for today's lesson. The first thing that we need to do is I just want to do a quick review or recap of factoring skills really quick, because that's kind of crucial to what we're doing today, because then you're going to solve some higher degree polynomial equations using those factoring skills. So I want to make sure you can factor. Then we'll solve radical equations. So we got three things that we're doing today. First of all, let's just recap factoring. I've showed you all this flow chart before, so I'll make a rough sketch of it now. Whenever you are factoring, I want your brain to follow this flow chart. So the first thing that you do anytime you're asked to factor is you're going to factor out the GCF if possible. If not possible, you can skip that step. But if there's a greatest common factor, you're going to factor it out. Then the way that you approach factoring polynomials depends on how many terms that you have. If you have two terms, a binomial, you're going to check to see if you have a difference of squares. That would be one perfect square minus another perfect square. They have to be perfect squares and they have to be subtracted, because difference means subtract. So perfect square minus a perfect square. That will factor into, it follows this factoring pattern, a plus b times a minus b, where a is the square root of a squared, b is the square root of b squared. So just a reminder, if I have something like x squared minus 9, x squared is a perfect square, 9 is a perfect square, that would factor into x plus 3 times x minus 3. Difference of squares. If you have three terms, you're just going to try to factor that trinomial. And we're going to do a little bit of guess and check here because it requires the least amount of writing. Sometimes it can be a little frustrating. You may have learned other methods in your other classes, but we're going to go with guess and check. Now, if you remember the other methods, again, you're free to use those, but you will see me use guess and check here. We're just guessing which numbers can go first and last to get the two factors to multiply to be that polynomial. Then, if you have four terms, you're going to use something called factor by grouping. And that's the approach you'll take based on the number of terms you have. You will find today that once you factor, you might need to go through this process again and continue factoring. So you might factor three terms into two terms, and you notice there's a difference of squares. So then you'll have another layer of factoring that will have to be considered. So let's put this to practice. So our first example is right here. We're going to factor this equation or expression completely. So first of all, is there a greatest common factor? The coefficients are 1, -8, and 7. They don't have any common factors in common. And all three terms do not have an x, so there's no greatest common factor. So now how many terms? I've got three terms. So then I'm going to break this into two binomials. What times what is going to give me x to the fourth? That's what goes in the first blank. X squared times x squared. So with these higher degree, just divide that higher degree by 2, and that's what you put in the first one. For the second blank, it goes right here and it goes right there, are things that multiply to be 7. So I'm gonna need to know what the factors of 7 are. Whoops, factors of 7. Well, 1 times 7 is 7, and that's it. So I'll put a 1 here, and I'll put a 7 there. Then I will need to check these products, the inner product and the outer product, to see if those will add or subtract to become -8x squared. So the product of 1 and x squared is x squared, and the product of x squared and 7 is 7x squared. Now, how do I need to combine x squared and 7x squared to be -8x squared? By making them both negative. -7x squared minus x squared is -8x squared. So that means, so you look and see how this connects, I need a minus here, and then I need a minus right there. All right, so we factored so far. Yay! But do I need to factor further? Are there any perfect squares? Well, look right here. X squared is a perfect square, and 1 is a perfect square. So that first set of parentheses, or that first binomial, is a difference of squares. So I can factor this part further into an x plus 1 times an x minus 1. The second part, is it a difference of squares? X squared is perfect square. Minus means difference. 7, not a perfect square. So I just bring that part down. And then this is now factored fully. So this is what I would type in for my answer when it just asks me to factor. Now, some of your problems will ask you to factor, some will ask you to solve. So pay attention to what it's asking for. If it just wants you to factor, then this is what you want for your answer. If the problem says solve, then you'll have to go a little bit further and figure out what x is. But we are not solving yet, we're just factoring. All right, let's do another factoring example. Higher degree equations, more factoring. 5x cubed minus x to the fifth plus 14x. Now on this one, notice that the highest degree is not on the end. So you always, here's a tip, pro tip, right here. Pro tip. Put in standard form. So put that in standard form. That means put the thing that has the highest degree first. So that would be the negative x to the fifth. So negative x to the fifth, and then a positive 5x cubed, and then positive 14x. Then I'm going to try to factor. So is there a GCF? Well, look, each term has an x, so I can factor out an x. And I like my first term to be positive, so since this first term is negative, I'll factor out a negative x. So negative x on the outside of my parentheses here. If you divide negative x to the fifth by negative x, I'll be left with positive x to the fourth. 5x cubed divided by negative x is negative 5x squared. And then 14x divided by negative x is negative 14. Then if I want to double check, if you distribute negative x to all three of these, I should have the line above. Okay, so now I notice I've got three terms left. So I need to take this trinomial and divide it into two binomials, here and here. But that negative x that I factored out still needs to be brought down. You're just going to carry it along every time. All right, so now let's factor. What will multiply to be x to the fourth? X squared times x squared. Divide that exponent by 2. Now it's going to multiply to be 14. So I come over here and I think, okay, what are some factors of 14? We have 1 times 14 and 2 times 7. So which one do I want to use? It's up to me. I can kind of play around with it, but I do see that I need a 5, and 2 and 7. If you subtract those, you'll get a 5. So let's try 2 and 7 first, and then I'll check the products. So this product is 2x squared. This product is 7x squared. If I make the 7 negative and the 2 positive, negative 7x squared plus 2x squared does give me the negative 5x squared that I need. So that means the 2 is positive, the 7 is negative, and it is factored. Let me erase these product lines. Now, can I factor any further? Are there any difference of squares? That means I need 2 perfect squares being subtracted. Well, this is not 2 terms. This is 2 terms. I have a perfect square, but I have a plus sign. That's not a minus sign, so not here. Then I have a perfect square, a minus sign, but 7 is not a perfect square. So no, I don't have any more difference of squares. And now we're finished. So this is what I would type in as my answer. Oops. Next example, example 3. Now we're going to start solving. So whenever you're solving, you need to find x. What does x equal? So the way that you solve by factor, step 1, you need to factor. There's really only 2 steps here, factor. So everything that we did before, you're going to do. Then you're going to go one step further and you're going to apply the zero product property. Which basically means that you're going to set each factor equal to 0. And I'll talk about why when we get there. 0. Okay, so let's try factoring. Okay, so first of all, I'm going to check for a greatest common factor. 16, 425, and 625 do not have any common factors, and not all terms have an x, so there's no greatest common factor, unfortunately. So we've got some big numbers we're going to have to work with, but we're smart, we can do it. So I've got 3 terms. I'm going to break these 3 terms into 2 trinomials. And this time I do have an equal 0, so I need to bring that equal 0 down. So first I need to figure out what's going to multiply to be 16x to the 4th. So I need to think about what are factors of 16. Factors of 16 are 1 and 16, 4 and 4, and 2 and 8. So I've got 3 options to choose from. I'm going to start at the top and I'm going to say a 1 and a 16, and I still need to multiply to be x to the 4th, so let's put an x squared here and an x squared there. Then I need to figure out what's going to multiply to be 625. So what are some factors of 625? Well, 1 times 625. 5, if I divide 625 divided by 5, 5 times 125. 25 and 25, and I think that's it. Okay, so I have 3 options to choose from. I do know that the products here are going to have to combine to be 425, so I'm going to try to be strategic about how I pick which one, but I might have to try a couple of different combinations before I land on 2 products that will combine to be negative 425. So let's see what happens. 425, let's see, if I take 625, I'm thinking this is not going to be a good option because I need to get to 425, and if I start with 620, I don't think that's going to work. So let's try the 25 and the 25. Okay, what is 16 times 25? 400. Oh, that's a good indication because I need to combine to get 425. So 25 times 16x squared would be 400x squared. And then what is 25 times x squared? That would be 25x squared. Will those combine to be negative 425? Yes, if they're both negative. So that means this 25 needs to be negative, that 25 needs to be negative. Now in this problem, we are working with bigger numbers. So as you're factoring, you might have to try different combinations, but it does help if you try to be strategic on how you pick the combinations. But you'll get there eventually. Just keep it up. Keep trying. Okay, so I have factored? Have I factored fully? Let's check. Is there, oh, I have a perfect square minus another perfect square. That's a difference of squares. So that will factor into x plus 5 times x minus 5, because x squared is a perfect square, so the square root of x squared is x. 25 is a perfect square, the square root of 25 is 5. Oh, perfect square minus another perfect square. That also factors into two perfect squares. The square root of 16x squared would be 4x. So I'll have a 4x for each one. And then the square root of 25 is 5. I'll need a plus and a minus in each one. Equals 0. All right, so factored. Check. Now we have to apply the zero product property, and then which means set each factor equal to 0. So here's what that means. All 4 of these binomials are being multiplied, and when you multiply them all out, they equal 0. Well, whenever you're multiplying, in order to multiply and get 0, one or more of these is going to have to be 0 itself. So if we're trying to find all the possibilities of x, then we set every single factor equal to 0 to figure out what x could be. So we'll say x plus 5 equals 0, x minus 5 equals 0, 4x plus 5 equals 0, and 4x minus 5 equals 0. But it's really important for this to work, you have to have it equal 0 over here. So make sure you make that equal 0 first. Solve each equation. I get x equals negative 5. Add 5 to both sides here. I get x equals positive 5. If I subtract 5, I'll have 4x equals negative 5. So divide both sides by 4. X would be negative 5 over 4. And then add 5 to both sides, you get 4x equals 5. Divide both sides by 4, x would be 5 over 4. Whew, that's 4 answers. But also take a look at the original equation. The degree of the equation, which you can find by looking at the highest exponent, that degree tells you how many solutions you're going to have. So if my degree is 4, I should have 1, 2, 3, 4 answers. Sometimes you get the same answer happen twice, but altogether there should be 4 answers whenever you're solving these. Now we're going to move into how to solve radical equations. So you might want to pause the video and copy these steps down. The first thing you need to do is isolate the radical. That means get the expression that has that radical symbol all by itself on one side of the equal sign. Step 2, you're going to raise both sides to a power depending on the index of the radical. So let's say you have a cubed root of something, then you would need to raise both sides to whatever that number is, which would be 3. If you just have a radical, then that's a square root and the index is understood to be a 2. So then in that case, you would square both sides. So whatever number is that index, that's what you raise both sides to. If you still have a radical left after doing these, you'll have to repeat these 2 steps. Most of the times you won't, but towards the end of the assignment you will. Then after that, solve for the variable, and then you're going to check for something called an extraneous solution. An extraneous solution is a solution that does not make the original equation true. Now this could happen a couple of different ways. Well, hang on. You can get an answer that doesn't make the equation true by making a mistake. That's not an extraneous solution. An extraneous solution means you did everything mathematically and algebraically correct. You did not make any mistakes. But the answer that you get doesn't work when you try to check it. That's called extraneous. And those happen whenever you're raising both sides, whenever you square both sides, because when you square something, it makes it positive, and it can really mess with the value of x. So that's going to happen when you have radical equations. I know it's really frustrating to be like, I did everything right, and that answer is not right. What? What are you telling me, Miss Honeycutt? But the reason that happens is because we are squaring things. Squaring things makes them positive, and then that can lead to issues later down the road. So we call it extraneous. All right, so let's try an example. First thing we're going to do is solve for x. So that first step was to isolate the radical. So that's this guy right here. I'm going to get it by itself by adding 15 to both sides. So now I have the square root of x plus 6 equals 1. Yay, the radical is isolated. Now I need to raise both sides to a power. So I'm going to square both sides because it's a square root. So the index is understood to be 1. Whatever you do to one side, you have to do to the other side of the equation. So square both sides. When you square a square root and only a square root, nothing else, just the square root, like the only thing in this parentheses is that square root. There's no plus or whatever. It cancels it out. So I now have on the left side x plus 6, and then 1 squared is 1. So solve the equation, subtract 6, and you get x equals negative 5 for my solution. But don't forget, you still have to check to make sure that that is correct. So you check that by substituting in that answer in for all the x's. So I'm going to substitute in negative 5 for x. I'll have negative 5 plus 6 minus 15 equals negative 14. Negative 5 plus 6 is 1. Minus 15, does that equal negative 14? Negative 14? Yes, it does. All right, so I have an accurate solution. It's not extraneous. Now these do get a little more complicated when you have an x on both sides. So let's look at what happens here. I can see that the radical is already isolated. So this equation is ready for me to square both sides. Square the left side, square the right side. I just have to be careful here because whenever you square x plus 3, that means you need to multiply x plus 3 times x plus 3. You need to multiply it by itself. So x plus 3 times x plus 3 distribute. We're going to get x squared plus 3x plus another 3x plus 9, which combines to be x squared plus 6x plus 9. So that's what's on the right side. Left side, the only thing I'm squaring is the square root. Nothing else. There's no other operation under that in that side of that parentheses. So the square root cancels. I just have 2 minus 2x. And I see because there is a x squared here, this equation is quadratic. So since it's quadratic, I need to try to solve it by factoring, which means I need to set it equal to 0. So I'm going to subtract 2 on both sides from the like terms. I'm going to add 2x on both sides to the like terms. So then I have the equation 0 equals x squared plus 8x plus 7. I'm going to solve it by factoring. X plus, let's see, 7 times 1 is 7. And then 7x plus 1x will give me the 8x. All right, apply that zero product property. X plus 7 equals 0, so x is going to be negative 7. And x plus 1 equals 0, so x is going to be negative 1. But don't forget, we have to check extraneous solutions. I've got 2 solutions here that I need to check. So the first one I'm going to check is that negative 7, which means that I'm going to take this equation here, and I'm going to substitute in negative 7 every time there's an x. So the square root of 2 minus 2 times negative 7, I want to see if that's equal to negative 7 plus 3. So that would be the square root of 2 plus 14. Is that equal to 4? 2 plus 14 is 16. And yes, the square root of 16 is 4. So that means x equals -7 is not extraneous. It is a solution. Okay, now we'll check x equals -1, which means I'll put a -1 here and a -1 there. So the square root of 2 minus 2 times -1, is that the same as -1 plus 3? So that would be the square root of 2 plus 2. Is that the same as 2? Which means I have the square root of 4. Yes, that does equal 2. So yes, x equals -1 is also a solution. If this were not true, you would just put an x through it, and that's what you would have. That's what you would say. But that's not the case here. X equals 1 is not extraneous. So x does equal -1. So this does have two solutions. All right, this will be our last example. And notice in this one, we have 2 radicals. So that will happen sometimes. And sometimes when you have 2 radicals, you'll have to go through the process twice. So if you've got 2 radicals, pick one to isolate first. The square root of x plus 5 is already isolated, so I'm going to say this is the one I want to isolate, and I'm going to square it. Square this side, square the left side. On the right side, the only thing that's being squared is this radical. So that allows me to cancel out the radical to get x plus 5 on the right. On the left side, I'm squaring a radical and then a plus 1 outside of the radical. So that means that I need to multiply that out. So x plus 1 squared means that I need to multiply the square root of x plus 1 times the square root of x plus 1. I've got to multiply all of that out. So the square root of x times the square root of x is x. The square root of x times 1 is plus the square root of x. 1 times square root of x plus another square root of x, and 1 times 1 plus 1. So I can combine these to be x plus 2 square roots of x plus 1. So that is what goes on this side. X plus 2 square roots of x plus 1. Oh man, there's still a radical. What did I say about having another radical after you do that? Let's go back to those steps. If you still have a radical left, repeat steps 1 and 2. So I got to go back and isolate that radical again, then raise both sides. So I need to isolate that radical. Okay, so I'm going to isolate the radical by subtracting the x on both sides from the like terms, subtracting the 1 on both sides from the like terms. So now I have 2 square root of x equals, x minus x is 0, 5 minus 1 is 4. Still have to isolate the radical. The radical is being multiplied by 2, so I'm going to divide both sides by 2. Square root of x now equals 2. Now I can square both sides. X will be 4. Yay! Now, I still need to check. So I'm going to substitute 4 there, substitute 4 there. So is the square root of 4 plus 1 the same as the square root of 4 plus 5? Square root of 4 is 2 plus 1. Is that the same as the square root of 9? Square root of 9 is 3. Yes, so this answer is also correct. That does it for today. Good luck on this assignment. If you need anything, feel free to contact me. You can click the Zoom link during our class block and come back and see me, or you can email me or schedule a help session. Have a wonderful day.